All right, so let's get started on lesson 2.1.2, making sense of different representations of a linear function. So to get started, let's go over some vocabulary words. The first vocabulary word is polynomial. So a polynomial is a math expression involving the sum of powers multiplied by a coefficient. You're probably wondering, what in the world does this mean, Miss Jade? So let's go over these polynomial expression examples on the bottom right over here. So all of these equations are polynomials. The first one is a constant polynomial. So this power is to the power of 0. So there's an invisible x to the power of 0 here. So that's a sum of powers. In the second one, you have a power of 1, so that's x to the power of 1, and the -5 is a power of 0. So you have two powers being added together. And then in the third one, you have x to the power of 2, x to the power of 1, x to the power of 0. They're all being added together, so it's a sum of powers. And then the last one is just x cubed and x 0. There's two powers there. They're being added together. And also, polynomials can be multiplied by a coefficient. So in this first one, your coefficient is 7. In the linear, your coefficients are 2 and -5. This one's coefficients are 3, -2, and 4. Cubic has coefficients of 4 and -2. So you can see that all of these examples, they got exponents and they're being multiplied to a coefficient. Therefore, they are polynomials. So that definition just means that all of these are polynomials. These are just some examples of polynomials. Okay, let's talk about leading coefficient. The leading coefficient is specifically talking about polynomials. So leading coefficient is the coefficient of the term with the greatest power. So what does that even mean? What is that? So let's take a look at these examples on the bottom in this chart. We have, let's take a look at the constant one. So this one has the power of 0. It's the only term there, so the leading coefficient, which I shall now highlight in purple, the leading coefficient is 7. In the linear, we have a coefficient of 1 and the coefficient of 0. 1 is greater than 0, so 1 is the greatest power. The coefficient in front of that is 2, so therefore the leading coefficient is 2. We also have the third one, which is quadratic. We have the power of 2, we have the power of 1, we have the power of 0, and 2 is bigger than 1 and 0, so 2 is the greatest power. Therefore, the leading coefficient would be 3. Finally, last but not least, we have the cubic function 4x cubed minus 2. So the power is 3, and then this power is 0. 3 is bigger than 0. Therefore, the leading coefficient would be 4. All right. Let's also do degree. So the definition of degree is the greatest variable exponent, meaning it's the greatest power in the expression. So essentially what it means is we're going to look for the biggest power. So taking a look at our constant example, the only power I see, the only exponent is 0. So therefore the degree is 0. In the linear example, we have 0 compared to 1. 1 is bigger, so the degree is 1. In the quadratic, look at all the exponents. We have a 2, we have a 1, we have a 0. 2 is bigger than 1 or 0, so our degree is 2. And finally, for the cubic, we have 3 versus 0. 3 is bigger than 0, so it's going to be 3. Let me do one more example for you guys. I'm going to write it on the side. F of x is equal to, let's do 12x squared minus 5x plus 4x cubed. What is our degree, first of all? So the degree is the biggest exponent. I have an exponent of 2, an exponent of 1, an exponent of 3. Which is the biggest? 3 is the biggest. Degree is 3. Now that we've found the biggest power, we found the biggest exponent, we can choose our leading coefficient, which is the number in front of the biggest exponent, and so that would be 4. So the leading coefficient is 4 because it's the coefficient in front of the term with the highest exponent. Okay? So hopefully you guys have written that down. Let's move on to 0 of a function. The 0 of a function is a number that makes the value of the function equal to 0. That means make f of x equal to 0. Okay? So for example, if you have this equation, f of x is equal to 2x plus 1, and I say, find the 0, then you're going to replace the f of x with 0. So literally make f of x into 0. That's why I said make f of x equal to 0. We replace the f of x with 0, and now we solve for x. So solving for x, I'm going to divide by 2. That way those cancel out. We have 0 is equal to x plus 1. And then we subtract 1 on both sides, and you get, negative 1 is equal to x. So I'm going to write my answer in a full sentence. The 0 of the function is negative 1. So in this example, the 0 of our function was negative 1 because that was the number that made the function equal to 0. Negative 1 is the number, we're literally reading our definition here. Negative 1 is the number that makes the value of the function equal to 0. So that's why negative 1 is our 0. Okay, so let's continue scrolling down. Let's go over the different forms of linear functions. So we have slope-intercept form, which is y equals mx plus b. M is the slope, b is the y-intercept. You are most familiar with this one already. Oops. Then we have general form in the middle. F of x is equal to ax plus b. So this is literally the exact same thing as slope-intercept form. It just looks a little bit different. It's just like my name can be Summer Ing or my name can be Miss Jade. I am the same person, but you can call me two different things. That's how I want you to treat these two. Okay, slope-intercept form and general form, exactly the same. They just look a little different. And that's also how I want you to treat f of x and y. Exactly the same, they just look different. So in both of these cases, you have m is the slope, also known as a is the slope, okay? A is the leading coefficient, according to our new vocabulary. Also, we have b is the y-intercept. The same thing on both of them, okay? So that's slope-intercept form and general form. Now let's talk about factored form. So look over on the right where we have factored form. We have that f of x is equal to a parentheses x minus c parentheses. A and c are real numbers. A is not equal to 0. And x minus c, when equal to 0, is used to find the x-intercept. We'll go over that in a little bit. So in our example problems on the bottom, we're going to write each linear equation in factored form. So to write it in factored form, we need to make it look like this. I'm going to show you guys how to do that. F of x is equal to, we're going to take this leading coefficient, this number 3, and we're going to divide it out of both terms. So divide 3 out of 3x, you'll be left with x. Now you're going to take this negative 15 and divide it by 3. What is negative 15 divided by 3? You will get negative 5. So then our final answer is f of x is equal to 3 parentheses x minus 5. Let's try that again. On the second one, we have f of x is equal to, we're going to take this negative 4 and we're going to divide it out of both terms. You divide it out of negative 4x, you're just left with x. And now you also have to do 32 divided by negative 4. Positive 32 divided by negative 4 will give you negative 8. So then our final answer will be f of x is equal to negative 4 times x minus 8. Let's do the third one together. And if I'm writing too fast, you can always pause the video. So for this one, we're going to divide out in negative 6. So you divide negative 6 out of negative 6x, you're left with x. Then you're going to divide the negative 6 out of negative 18. So negative 18 divided by negative 6, you get a positive 3. So therefore, your answer is f of x is equal to negative 6 times x plus 3. I'm going to give you guys some time to try 4, 5, 6 on your own. So pause the video and try 4, 5, 6 on your own. All right, so now we are unpaused. I want to remind you guys that if you got it wrong, don't worry, just try to fix your mistake, understand where you went wrong, and if you don't understand it, you can always call me over to ask. All right, so for number 4, this is what you should have gotten. F of x is equal to negative 5 parentheses x plus 3. When you divide negative 15 by negative 5, you get a positive 3. That's why it's x plus 3. Number 5, you should have gotten this. So if you take the 49 and you divide it by 7, you should get a positive 7. That's why we have an x plus 7 over there. And finally, for number 6, you take the negative 9 out, and you should get this. So when you divide positive 54 by negative 9, you should get a negative 6. So hopefully you guys got 4, 5, 6 correct. If not, that's totally fine. Just make sure you correct yourself and ask me if you need any help.